Hello friends, welcome to Shiksharthi. In this video, we shall discuss cubic equations. So let's start. So if you recollect my first video on cubic polynomials, we had basically talked about how is the cubic polynomial formed, and thereafter finally we talked about the different types of cubic polynomials. I hope you have gone through the video, which makes you take this discussion to the next level. The next level is where we had basically talked about 6 different types, and the 7th type was nothing but the extension to the 5th type only. But if you wish, you can take it further and you can say that even a linear polynomial can be formed in 2 different ways. You know which way. One is of the form ax and the other is of the form ax plus b. And a quadratic polynomial can also be formed in 4 different ways, because we know that ax square has to be there in any case, and the remaining 2, I keep on eliminating. So either I have all the 3, or I have exactly 2, or I have exactly 1, right? So these cases can be further divided into subparts, and maybe the total count of cases you can count it on your own if you want to take this discussion to the next level. I hope by now, after watching so many videos of ours, you would have understood what do we mean by taking the discussion to the next level. So on the face of it, what you're expected to do is, when it is suggested that you should take any discussion to the next level, means what? You should revise it, and the next level is you have to have some fruits out of that. Maybe the hint that I gave you a few minutes back. Okay. So coming back, now we are going to talk about cubic equations. So the moment we say any of a cubic expression, any of this, if I equate it to a 0, this is how a cubic equation is formed? No, this is not the only way. How can I form a cubic equation? I can have, so equation has an equal to sign in between. On one hand, on one side, I can have a cubic polynomial. On the other side also, I can have a cubic polynomial, such that the cubic polynomial should not get eliminated, right? Or on one side of the equation, let's say from your side, the left hand side should have a cubic polynomial, the right hand side should have a quadratic polynomial. The left hand side should have a cubic polynomial, and the right hand side should have a linear polynomial. The left hand side should have a cubic polynomial, and the right hand side should have a constant polynomial. Even this constant polynomial can be a non-zero constant or a constant like 0. So how many cases have we discussed? If you just rewind this video, and you would see we have talked about 5 cases: cubic quadratic, cubic linear, cubic constant, and in constant we talked about 2 different cases. So this is how a cubic equation is formed. Okay, having said this, now let us talk about what is, we have talked about this in other videos also, but talking about this video, if I say a cubic 0, there is a terminology which we can always use here, is a 0 is just like saying real roots, right? Is just like saying x-intercepts. These are synonymous terms. So if I say 0 of a polynomial, so when I say 0 of a polynomial, I am basically talking about real roots of the polynomial, right? And at the same time, when I am representing this on the Cartesian plane, so mark the words being used, since we had talked about that we are only talking about real values, which is why we are using a terminology like Cartesian plane. And as of now, we are only talking about a cubic polynomial or a cubic equation in a single variable. We can talk about more than one variable as well, but not as of now. Okay, so x-intercepts is when I represent this cubic polynomial on a real xy plane. So these are synonymous terms being used. So now if I take this up and if I compare, let us say, the first type with the 7th type. So the first type, I can rewrite it as the first type. I can rewrite it as a times of x cube plus b by a plus c by a plus d by a. I can rewrite it like this, keeping in mind that none of them, I mean at least a is a non-zero. At least a is a non-zero real value. Since we are talking about real values, at least one of the coefficients is a non-zero. Now when I am saying at least one of the coefficients, I am taking care of all these 4 cases broadly that I had made. We are talking about this. Okay. Then the 7th one that we had written. So if I rewrite the 7th form, it is just like saying this is a times of x minus alpha into x minus beta into x minus gamma. And as of now, we have not equated it to a 0, because the moment I equate it to a 0, it is then only I talk about the zeros of a polynomial. Mark the words being used. When we talk about the zeros of a polynomial is when that particular polynomial is equated to a 0. Equating to a 0 means what? We are talking about real roots, or we are talking about real factors. If I am talking about merely the polynomial, in that case it becomes the factor, because if you would see, these are nothing but the factors only. What are factors? You are multiplying them with each other. So the moment you equate a polynomial to a 0, whether it is a linear polynomial or it is a quadratic polynomial or it is a cubic polynomial or any other polynomial which is greater than this in terms of the degree of the variable that has been used. And I hope you are aware of the fact that the degree, the word degree, is nothing but, here I would say the degree is decided by if this is my first term, this is my second term, this is my third term, and this is my fourth term. So the degree of the fourth term is 0, because the variable that is being used here is the power of that variable is a 0. Here the degree is 1. Here the degree is 2, and here the degree is 3. Now when I combine all of them, in that case with the help of the operators. Now what are the operators we are basically talking about? We are basically talking about 2 operators. One is addition and the other one is subtraction. If I would have used a subtraction also in between, still the degree would be the maximum degree of all these terms. So if I see the maximum degree of all these terms is equal to a 3, which is why we call it as a cubic equation. And here we are talking about a cubic equation of degree 3 in a single variable x is what we are talking about. So even if I change this operator to a let's say a negation, subtraction, not division as we talked about in the earlier video, not multiplication, because if I multiply them, or let's say I multiply any 2 of them which are lesser than this. So let's say if I'm multiplying these 2 or these 2 or these 2, but then I'm using a plus or minus here, in that case the degree still would be a 3. But if I multiply all of them, in that case the degree becomes a 6. Which no longer makes it a cubic polynomial. So coming back, I hope by now you would have understood that now we are going to talk about either the real factors or we are going to talk about the real zeros. Now what I want you to do here is, or understand here is, if I equate both of these, so let's say what am I saying? I am saying let 1 be equal to 7. So in that case both of these they get cancelled out, and then I can rewrite this equation as this is nothing but a times of x cube minus x squared times of alpha plus beta plus gamma plus x times of alpha beta plus alpha gamma plus beta gamma minus alpha into beta into gamma. I can rewrite. So when I compare these two from here, when I'm comparing these two, basically it will boil down to the comparison. So when you're comparing these two, it's just like saying on one hand you are writing a cubic equation, let's say a cubic polynomial, on the other hand also you are writing a cubic polynomial. So please mark the discussion that I have already done with you. A cubic polynomial is a polynomial which on either side of the equal to operator will be either a cubic, square which is quadratic, cubic, linear, cubic, constant, non-zero constant, or a zero constant. Okay, so when I equate this, so in that case what will I get? That is something that needs to be ascertained. So what will I get? Eventually you get an equation. So you will get an equation like a times of, so now this a x cube, it gets cancelled out, and then you'll be getting what? So let's say if I take which expression on the other side, so let's say that I am doing 1 minus 7, then it becomes equal to a 0. So 1 minus 7 is just like saying for the coefficient of, so I'm sorry, here I should have written x square, here it is x and then d by a. So this can be rewritten like this. Please mark the change which has been done here. Okay, so now when I say equation 1 minus equation 7 from here becomes equal to a 0. So from here what are we saying now? We are saying x square times of, so let's say let me use a curly bracket, b by a minus of this becomes plus, and then this minus this is just like saying plus, so plus x times of, again let's say the curly bracket starts, so c by a minus alpha beta plus alpha gamma minus, let's say, plus beta gamma, this closes, and then this minus this, which becomes what? Plus, curly bracket starts, d plus alpha beta gamma, curly bracket closes, square bracket closes. Now this becomes equal to a 0. This entire expression becomes equal to a 0 because when I say let's say this expression, this cubic expression become equal to this. Now in that case, when will this become equal to a 0? This will become equal to a 0 only when a is a non-zero real value, and at the same time all of these, if they are equated to a 0. So it is just like saying 0 plus 0 plus 0 becomes equal to a 0. So from here you will get alpha plus beta plus gamma is equal to minus b by a. Then you are getting what? You are getting alpha beta plus alpha gamma plus beta gamma is equal to c by a, and finally you are getting alpha into beta into gamma is equal to d by a. And now why are we saying d by a? Because this was d by a, so let's rectify it to be a d by a. Okay, and this becomes minus d by a. So please note, what are we getting? We are getting minus, then plus, then minus again. So from here you get what? These, you get the zeros. Now the moment you say that you had equated to a 0, that means now you are talking about the zeros of this cubic polynomial. That means here now the inference here is we are talking about alpha, beta, gamma as the real roots of this, as the real roots, because this equation has been equated to a 0. It's when you compare expression 1 cubic expression with the another cubic expression, then you get what? The sum of the real roots, or the sum of the roots is minus b by a. Product of any two roots taken at a time and then added gives you c by a, right? And then the product of all the three roots taken is equal to nothing but minus d by a. This is what you get when you equate it to a 0. And then you talk about all of these. So now we are talking about, since we are talking about real roots, so we are talking about the sum of the three real roots will be equal to minus b by a. The product of any two real roots of a cubic equation when added, any two roots, when you take the product and then their sum gives you c by a, and the product of all the three roots when taken here gives you d by a. So here now we are talking about, finally we talked about the cubic equation, and then we talked about the zeros of a cubic equation, and the zeros of a cubic equation when we are talking about, then we are talking about zeros of a polynomial or a cubic equation. Cubic polynomial in this case will be nothing but the real roots, and when we are talking about three real roots, the sum of three real roots would be minus b by a, and then the other two things that we have talked about. right? So if you recollect, in a quadratic equation we had only two outcomes because the maximum power of a single variable that you had used there were 2. Here you are having 3 different outcomes for 3 roots. Why? Because the maximum polynomial value that you are using here is 3. Had it been a biquadratic polynomial, biquadratic is when you take the maximum power of a single variable here as x. In that case you should have had 4 outcomes. And what are the 4 outcomes you could have had? So once you are talking about a root taken at a time, 2 roots taken at a time, then there's some 3 roots taken at a time, then there's some, and the 4th thing is when you're talking about the product of all the roots taken together. So if you feel that this video was really informative and it takes your learning to the next level, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get updates from us regularly. If you want us to do some videos on specific topics, don't hesitate, put it in the comment section so that we do it for you. Thank you so much. Until next we meet, goodbye.